Okay, the area of any parallelogram, which includes rectangles and squares and all the other such, is base times height. Okay, so your goal is to get the base, which you have. The base is 28, but you really want this height right here. Okay, and that's what makes this problem a little bit harder. They don't just give you the height. They kind of do though. That's not big enough here. They kind of do because you can calculate it from that triangle there. So this is 30 degrees. The hypotenuse is 30. This is a 30, 60, 90 triangle. Do you remember that from a while back?
Yeah.
Okay, so the way this goes is the short leg, which is across from the 30, is x. The hypotenuse is 2x. And the other leg is x root 3. Which are they giving you? Are they giving you the hypotenuse, the short leg, or the long leg?
The hypotenuse.
Hypotenuse. So you can see that the short leg is 15. You cut it in half. You don't actually want that. That's the one up here. You want the long leg. It's 15 square root of 3. So in your problem here, the base is 28. The height, though, is 15 square root of 3, like that. Oh, and you're rounding to the nearest 10th. Okay, so you're just going to go to your calculator with this anyway. I was going to say, oh, we can do something here, but nope.
727.5.
727.5 feet squared. All right. So 18, really similar. We're going to have to calculate one of the
Wait.
lengths.
For 17, do we have to add it to?
Nope.
Don't we have to?
So you're finding the area of this. Area is base times height. The base is given.
Oh, yeah, that's right.
We had to
Okay.
calculate the height.
And the height
18.
is 15 square root of 3.
Yes. Okay. All right. So next one here, the base this time is this, believe it or not, is this 14 is the base. It can sit on either end. So we'll call that the base. The height is this leg of the triangle. So that's 60 degrees, 7 there. Again, it's a 30, 60, 90 triangle. So this is x, this is 2x, this is x root 3. The height is again here 7 root 3. Since they're giving you the x side or short leg side. Right. So your area is base times height. Base is 14. The height is 7 square root 3.
– 169.7.
Yes.
Millimeter square or square millimeters.
Good. All right, 19 here. All right, so we got a similar situation here. You can always use the top as the base if you want, and I would recommend doing that. So the base is 33.5. The height is again this here, but it's a different type of triangle. It's a 45, 45, 90 triangle. Okay. So the reference triangle for 45, 45, 90 is the legs are the same, x, which is what you need here. You need this other leg, which is the same 10.1. There's no calculations to do there.
Nice.
So the area is 33.5 times 10.1.
338.4.
A slightly different number. 338.4. So
Or 0.6, sorry.
okay.
0.6 centimeters, square centimeters.
All right. Next one here. Next one is really similar. Do you want to try 20 on your own? It's really similar to 19.
Mm-hmm.
Actually, I take that back. It is a little different here. The base is 12.8. This time, the reference triangle shows that you're given the hypotenuse. So this, I don't know if you remember this from when you're doing triangles, you set the known side equal to the reference side. 6.4 equals x root 2.
Oh,
Okay. And you have to divide both sides by root 2. Because we're rounding for our final answer, we're just going to go right to the calculator. We don't have to rationalize this or anything. But go ahead and round it like 4 decimal places for now.
okay. Uh, 4.5254.
Okay, that's close enough. So that is your height here, because x is both the height and the base of that triangle. So as long as you get one of them, you can get the other. And then your area is base times height.
So that times 12.8. 57.9.
Yes, we got 57.9 inches squared. Good. Right, so 21 is actually the easiest problem we've seen thus far, because they actually give you both the base
Oh yeah.
and the height. There's the base, there's the height. Nothing to do here. Intermediate calculations.
480 square meter.
Yeah, good.
Meters.
Which means the next one will be either just as easy or like doubly difficult to make up for the last one. But we'll see here. All right. So I can't really do it, and I don't want you to rotate your head so you don't get a crook in your neck, but this 22 here is the base.
Oh, okay.
Okay, so just consider the base. So the height, this is the height over here. And I don't like when these triangles are drawn sort of awkwardly, so I'm going to redo it here. And we're trying to find that height there, h. Hopefully you can see
Yeah.
see that there. All right, so we got to find the height. This one is not a special triangle. It's a sine, cosine, tangent problem. Okay, so relative to this angle, what is 18 and what is h? And your answers are adjacent, opposite, or hypotenuse. Can you remember? Can you tell me what that is? Like which one 18 is really?
To h, it's gonna be opposite and adjacent.
Good. And do you remember now if that is sine, cosine,
Tangent.
It is tangent. So the tangent of 40 degrees equals 18 over h. Right. So solve for h. You got to undo this division by h, multiply both sides by h, and then divide by tangent of 40. I think we've seen that a few times. I've also shown you, I think that you can just swap positions here. So it's h equals 18 over tangent of 40.
$21.5.
Okay.
For
That is
the
not that, yeah. And that you want to go to a few more decimal places on that one. Like I would go
okay.
out, basically double the precision of your answer or more is recommended for these types of intermediate calculations. Not always works, but pretty much works. So your area is base times height. Your base is 22. You now have your height. Distance is 6. Okay. You want to go ahead and calculate that for us, please?
471.9 square centimeters.
Yes.
Nice. And we don't have to do 23.
Oh, but I really wanted to do that one. All right, let's go to 24 here. So the
23,
rest,
28, and 29, we can cross
okay.
out.
All right. So the next grouping of problems here, there's no pictures. These are the more challenging ones. I'm going to ask you to try to draw this as best you can. The parallelogram always looks something like that, but if you prefer the one that goes the other way, that's okay too. All right. But I'd like you to choose one and just kind of label as much as you can based on what you see.
Okay, so what I did is I put the base of the parallelogram as x, and then for the height, I did x plus 4.
Good. And then the whole thing is 221, right?
Yeah.
Good. So it's base times height equals 221. So to solve this, we have some options here. You will be distributing x, and then you move the 221 left. So you're, as a geometry student, you're supposed to say, oh, I know how to solve every quadratic because I learned that in algebra 1. And maybe that was true at the time. You may have forgotten, but you can factor. Usually that's the first one students do. Quadratic formula, it always works. You can graph. Any of those stand out to you about what to do to solve this?
I think factoring.
So factoring is good here. The only issue is because 221 is so large, it's kind of like, well, what two numbers multiply to 221, negative 221 that add to 4? So you do have a calculator. So what you would do is you would sit there and start dividing 221 like by 2 and by 3 and by 4 and by 5. And eventually you would come up with the pair that works here.
Oh.
You know what I mean by that or not? Okay. Do you want to try that for a moment here? I won't have us take up too much time, but that is kind of the general strategy here.
Well, I got up to 12 and none of them are.
Go to your next one more. You're almost there. 13 and 17 work. So it's x plus 17, x minus 13 equals 0. And then you set each of those equal to 0, x plus 17 equals 0, x minus 13 equals 0, x is minus 17, x is 13. So we use the positive one. Does that sound reasonable to you without much explanation?
Yeah, 1 second. Sorry, I just kind of forgot all about the like the factoring and
Yeah.
putting the so the numbers we put in the parentheses are just the two factors.
Yeah, like it's either 13, sorry, it's minus 21. So it's either 13 and minus 17 or minus 13 and 17.
Oh, okay.
And you find the one that adds to positive 4, and that's why it's this top one.
Oh.
Don't get too hung up on that because you're not going to be doing a lot of this in geometry. You will do it again next year. You can remember it next year if you want.
Yeah, 17. Yeah. Okay.
Is that okay? Can we move on to 20? Oh, I'm sorry. Yeah, I guess that is it. The base is 13. Let me draw it.
Oh, yeah.
Because we got to go back and actually do it. So the base is 13. The height is 13 plus 4. And these are in millimeters.
$17 millimeters. Cool.
Okay, so next question's kind of similar. It says the height of a parallelogram is 1/4 its base. So the height is 1/4 its base x. Notice that I don't try to draw it to scale. That doesn't really matter.
Mm-hmm.
All right, so the base times height x times 1/4 x equals 36. Just like the last problem. This one's easier though because there's no factoring. You just multiply the x's, keep the 1/4. Maybe you remember how to solve this one. No factoring needed this time.
Equals 36. Divided by 1/4. So x is 12.
X is 12. I agree. They want the base. That's 12. 1/4 the base is 3 centimeters. All right. 26. Is that good to do?
Yep.
Okay. All right. The base of a triangle is twice its height. There's a lot of different triangles you can draw. I'm going to always go with a right triangle here. So the base here is twice its height. So here's the height. The base is 2 times the height. Or if you prefer x, we can go x and then 2x here. So the challenge, the real challenge is the setup. It's to actually, put things in the right place here. Occasionally you can get away with kind of switching them, but it's still working out. The other thing is you got to remember all the area formulas. You remember the area of a triangle formula from class?
Base times height divided by 2.
You got it. So 49 equals base 2x times height x divided by 2.
Seven is x.
Yes, x is 7. Very good.
So the height is 7.
Yes.
And the base is 14.
So the base is 14 feet and the height is 7 feet. All right, so let me drop this in the chat. I found this for another student the other day, and I think it's actually the best reference sheet I found for area and volume. That's got everything kind of in one place. You might find that useful. Print that out, bring it to class, or
Oh,
just.
dang, yeah.
All right, so let's go to 27. 27 is like 26. Another triangle problem. All right, the height of a triangle is 3 meters less than its base. So here's the base. Height is x minus 3. The area of the triangle is 44 square meters. So 44, like you said, base times height divided by 2. X times x minus 3 divided by 2. Now this one's not as nice as the last couple. Does involve factoring. So we're gonna multiply both sides by 2. 88 equals, and then
X squared.
yeah, x squared minus 3x, and then I'm gonna move the 88 over so it's on the same side like this. This is another one of those, you got to find two numbers that multiply to minus 88 but add up to -3. So rather than starting at 1, 2, 3, like it's okay to pick something in the middle, but you know, it's like, where do you go? And I'm not sure what to tell you here, but if you start at like 5, probably have a better shot of getting it than.
Wait, which two numbers have to add up to -3?
So it's the two pairs here, like it could be -1 and 88, which is, see how those add up to 87. They're too far apart.
Oh, okay, yeah.
Or like -2 and 44. I mean, that's getting closer, but not much better.
Yeah. So -8.
Yeah, so is it -8 and 11 or 8 and -11? You want the one that adds up to -3 this time.
Oh, -8 or -11 and 8.
Yes. X minus 11 x plus 8 equals 0. And so you set them both equal to 0, but you only want the positive answer because we're talking about lengths of sides.
So x equals 11.
And the other one ends up being 11 minus 3 or 8. And what are our units here? Meters. Meters. All right. I think you said to skip maybe 28. Not sure. 29
29.
and 29. So go into 30. Is that right?
Mhm.
All right. So 30 kind of brings us back to some of the first couple that we were doing, meaning you're going to use some special triangle stuff here. So I'm going to just grab the bottom triangle here. The hypotenuse is 2 root 2. Whenever the two legs are the same, we know that that's a 45, 45, 90.
Mhm.
And that's x, x, x root 2.
Okay. So then we would just solve that.
Yeah, you want to get the value of x so that you can figure out the two legs, or they're the same in this case. And then we can find the perimeter.
Nice. And then Matthew, it's 4:30. I
Okay,
just don't want
you
to
do?
charge you for any.
Okay. No, so you're good to stop here? It's totally up to you.
Yeah.
All right. We can go ahead and stop. Let me just stop the recording real quick.